Hello everyone, my name is Mihailescu and I will be walking through my final coding project. The goal of my project was to model the spread of factory pollution with wind. Factories release many different compounds, one of them being sulfur dioxide, which reacts with water and oxygen in the air to form sulfuric acid. Sulfuric acid is the main compound in acid rain, which seeps into the ground and dissolves essential nutrients plants need. Knowing how factory particles interact with compounds in the air and where they end up is important in determining which ecosystems will be most affected. The project displays factory particles interacting with air particles, all of which are moved by matrix-modeled wind. I'll now explain the basic thought process behind the project. The project was coded in Python. There is one class that dictates particle object creation as well as movement. A separate file contains the code that will display the plotted simulation. Here, oxygen, nitrogen, factory particles, and sulfuric acid particles are generated. The wind matrix exists in this file as well. Oxygen and nitrogen are initially present and randomly generate in atmospheric proportions. Here are some main challenges of the project. Before even coding, I thought that the number of particles that needed to be generated with remembered locations was going to be incredibly challenging. The use of object-oriented programming definitely helped this problem since the locations of each particle is automatically stored. In actuality, the wind modeling was the most difficult. A diffusion model was first employed, where the space surrounding the particle was split into 8 sections of 45 degrees. The number of particles in each eighth was counted, and the particle in question moved to the eighth with the least number of other particles. The issue with this method was that processing power did not allow for there to be enough particles generated at a time, and it would significantly slow down the animation. In addition, diffusion dynamics is not necessarily the most accurate way of representing wind. The final product employs matrix-modeled wind, where 2 directional matrices, one to move the particle in the x direction and one to move the particle in the y direction, were generated. The coordinate location in x and y of the particle in question was rounded down, and the dx and dy values in the row and column from the directional matrix that corresponded with the coordinate point dictated the direction that the particle moved. All particles move at the same speed, so the net change in direction each time is 0.01 plot units. Here I will now show an example of diffusion modeled wind. You can see the fewer number of particles. Here is a video example of matrix-modeled wind. There are some white gaps that form, so it is not perfect, but it can definitely support significantly more particles. So here is an example of some white that is created, and here as well, white gaps. So here are some final thoughts on the project. The user can input different wind matrices to model different wind patterns. In addition, the user can change the area that is covered. In the previous videos, it was set to what it is defaulted at, and which is also its maximum, 10 miles by 10 miles. The skills learned is the versatility of object-oriented programming, plotting and animation functions, and maximizing processing time. This was mainly done by deleting particle objects that no longer appeared in the area space. Thank you for listening about my project.